Okie dokie. In this problem, we will be using the same method that we did in 315F. So I recommend maybe checking that video out first if you have not already done so. So the idea in this problem is we are given a function and we want to find the indefinite integral. So the integral of this function, and the method we will use is u-substitution. So the idea is we find our u first. Our u is usually whatever's in parentheses and being acted upon by another piece. So we have this in parentheses, but this is kind of just on its own. But this is in parentheses, x to the 9th plus 6, and it's being raised to the 2000. So the x to the 9th plus 6, our u, is always our inside function or inside expression. So if u is x to the 9th plus 6, we find our du, which is the derivative of u. So 9x to the 8th using the power rule. And then plus 6 goes to 0. And then I always recommend tacking on dx to the du. Then we want to solve for dx. So we get dx by itself on this right side by dividing by 9x to the 8th. Then the next step is to replace the x to the 9th plus 6th here with u, and then replace the dx here with du over 9x to the 8th. So we're rewriting the integral as u to the 2000th times negative 27x to the 8th. We're going to leave that the same. And then dx is du over 9x to the 8th. So we make these substitutions with u and dx, and then keep in mind our goal is to eliminate all the x terms, getting everything in terms of u and du. So we see we have an x to the 8th over an x to the 8th, and so they can cancel. And so what we're left with is negative 27 over 9. Negative 27 over 9 is just negative 3. Inside the integral or outside, really you could pull a constant out if you wanted to. And so all we're left with is negative 3, u to the 2000th, and du. So now we can find the antiderivative of this. The antiderivative is, well, we start by leaving the negative 3, and then we add 1 to the exponent to give us 2001 in the exponent, and then we divide by whatever that new exponent is. So dividing by 2001, and then we say plus c, and then the answers will be in terms of x. That means we have to get this u expression back in terms of x by substituting back in x to the 9th plus 6. So in place of u, we write x to the 9th plus 6. And we are looking for this answer. I might recommend looking for the fraction, like the coefficient first. So the 3 over 2001. And it looks like we see a 2001, but no 3 on top, right? And then there's like a 667 and a 9. And then this, so likely this fraction reduces. So let's see what happens if we divide the top and bottom by 3, because I think we see a potential answer, but we just want to confirm. So 3 over 2001. If we divide each of these by 3, so the 3 by 3 we get 1, and then 2001 divided by 3 we get 667, right? So really the reduced form of 3 over 2001 we see here is 1 over 667. So as a simplified answer, we would have negative 1, basically, or just negative x to the 9th plus 6 to the 2001 all over 667 plus c. All right, so it looks like option D is our best answer. All right, I'm gonna go ahead and work out 2 more examples a little bit faster this time. Let's give it a go. So the inside of the parentheses that's being acted on by an outside piece is our u, so 1 minus 7x squared. Du is our derivative of u, so we have negative 14x from the minus 7x squared the 1 goes to 0. Tack on dx. We're going to solve for dx by dividing by negative 14x. We substitute into our integral, so keep in mind this is basically like the integral of all this and then dx. Excuse me. So then we have, in place of 1 minus 7x squared, we have u, so cosine of u. We keep the negative 98x, and then in place of dx up here, we substitute du over negative 14x. Now, we cancel out our x terms so that everything's in terms of u and du. Then we have negative 98 over negative 14. I want to say this is 7. Let's check with Desmos. So negative over a negative is going to be positive. So 98 over 14 is positive 7. So we have integral of positive 7 cosine of u du. That's nice. This is much cleaner than the original integral. That's the whole idea behind u-sub. It simplifies what your integral looks like. So now, antiderivative. We leave the 7. It's just a coefficient. Antiderivative of cosine is sine, positive sine. And then we have plus c. So now, keep in mind, we could probably see our answer just based on the coefficient, the 7. And so if we wanted to, we could sub back in the 1 minus 7x squared in place of the u here and get our answer D. All right, let's go and do one more. Again, the inside of the parentheses being acted on by something else, another piece, is the u. So we have u is x to the 9th plus 4, which makes du 9x to the 8th dx, and then du over 9x to the 8th is equal to dx. So now, treating this all as an integral of dx, we replace or substitute in the u in place of the x to the 9th plus 4. So we have u to the 2000th. Keep the negative 18x to the 8th, and then sub in the dx, which is du over 9x to the 8th. The x terms will always cancel as long as u-sub is working. If they don't cancel, then double check your derivative, right? So we have negative 18 over 9. That will give us negative 2. And the rest is just u to the 2000th du. So then antiderivative, leave the negative 2, add 1 to the exponent, divide by whatever the new exponent is, plus c. All right, so now we are looking for, really again, just look for the coefficients. We want negative 2 over 2001, and that looks like option D once again. All right, I hope this method makes sense. If you have any questions on any part of this, please let me know.